Okay, here we have a question about binomial probability, and we're looking at the probability of getting a red marble when you know that the proportion of red to green is 7:3. So from that, we know that the probability at any time, because there are a large number of marbles, the probability of getting a red marble is always going to be 7 out of 10, or 0.7, whoops, or 0.7. So using the binomial, I'm going to take n to equal 5. Remember, n is the number of times the experiment is done. In this case, 5 marbles are taken. P is the probability of success. Well, that's 0.7. Q is the probability of failure. Well, in this case, that's getting a green marble. That's going to be 1 minus P, so that's going to be 0.3. And I'm going to take X to be the number of red marbles that I take, so the number of reds. Part 1 then says, what's the probability that all 5 are red? So we want the probability that X is equal to 5. Now you can either do this logically by saying if you've got 5 marbles and you know that the probability of any one of those marbles being red is 0.7, then the probability of getting 5 marbles is actually, which are all red, is 0.7 times 0.7 times 0.7 times 0.7 times 0.7, which is 0.7 to the power 5, and that comes out as 0.16807. Or you can use the binomial formula. Now the binomial formula says that you're going to do 5C5 times the probability of success, well that's 0.7 to the power 5, multiplied by 0.3 to the power 0. Well, that's actually just 1. And this, if you work it out in your calculator, is also just 1. Again, we've just got to work out 0.7 to the power 5. And again, you get the 0.16807. Right, the probability then in part 2 says you want the probability that X is equal to 3, that exactly 3 are red. And that's not quite so straightforward. Now, what we need to work out is 5C3 times the probability of 0.7 success happening 3 times multiplied by the probability of failure, well that's getting a green happening the rest of the time, which is twice. Now to work out 5C3 you can either use your calculator, so the NCR button, type in 5C3 and that will come out as 10, or you can use Pascal's triangle. So we're looking for the row of Pascal's triangle that goes like this. So 1, 3, 3, 1. Remember, we're adding these two numbers to get the ones underneath. So 1, 4, 6, 4, 1. We're looking for the row of Pascal's triangle that begins 1, 5, 10, 10, 5, 1. So this row here, this is 5C0, 5C1, 5C2. This is 5C3. So again, we're going to get 10. So I'm going to do 10 times 0.7 cubed times 0.3 squared, and that comes out as 0.3087.